Hello everyone, this is Saksham Jain and I welcome you all to the Future Camp. So in this video, we will be covering bias, variance, bullseye diagram related to bias and variance, and at last we will be dealing with bias-variance trade-off. So before I get started, I want to remind you that if you want to watch this whole video in Hindi, then you can find the link for the same in the description below. So please do check it out. Let's get started. The first question that might be popping in your mind is that what is bias? So the meaning of bias is that bias is the distance, or we can say the gap between the predicted value and the actual value. Predicted value are those values which our ML model has generated as the output, and the actual values are those values that should have been generated by the model, or I can say that the actual values are the correct values, the correct outputs. Bias represents the gap or difference, distance or difference between the actual and predicted values. More the bias, more is the distance. Less the distance, less the bias. If we have a high bias condition, then we can say that it is a condition of underfitting. Now let's talk about variance. So variance measures the degree of spread of our data set. Variance also measures the variability of our data set and predicted values. So if we talk about high variance condition, then we can say that if a model is having high variance, then its major of most of its focus or most of its attention goes towards training data. It tries to fit well in the training data. Therefore we will get a high accuracy in case of training data, but less accuracy in case of testing data or any random data. So this is called variance. So where do we use the concept of bias and variance? We use the concept of bias and variance in supervised machine learning problems. In supervised machine learning problems, whenever we have to create an algorithm or make a model, then we have to make sure that it gives us a very high accuracy. In order to high accuracy, that model should have a perfect balance between overfitting and underfitting condition, or we can say low bias and low variance. If a model has low variance and low bias, then we can say that that model is very good at predicting values and generating high accuracy. Now, whenever you see any blog related to bias and variance, or whenever you see a blog related to bias or variance, then you might have seen this diagram. So this diagram is known as the Bullseye Diagram. Here in the first column, you can see that the first column represents the condition of high bias and low variance. So let us suppose the center of this circle, or we can say the bullseye, represents the actual value. That is the value that is the correct value that the model should have generated. It is a correct value. So in case of high bias, there is a large gap between the actual and the predicted values. So suppose this is my actual, this is the place of my actual value, and therefore since it is having high bias, therefore my data set will be, my predicted values will lie here, somewhere here, because there is a huge gap here in order to provide huge gap. And also since it is a condition of low variance, therefore all the predicted values will not be scattered much relative to each other. They will be in a form of a cluster, they will be form of a group, they will be together. So my predicted values will look like this. They will be in form of a small cluster that are far from the actual values. In the second column, it is condition of high bias and high variance. Because it is of high bias, my predicted values will be situated far from the actual values, but also it is the condition of high variance. Therefore, all the predicted values will have a gap with respect to each other. So my predicted values will look like this. They will be scattered. They will be not in a form of a group. They will be scattered. In the third column, it is a case of low bias and low variance. So it is the ideal condition. It is a condition where the model provides us the best of its accuracy. Since it is of low bias, therefore all my predicted values will be lying nearer to the actual value. So my predicted values will be somewhere here. But also, since it is a condition of low variance, therefore they will be in a form of a cluster. They will be in a form of a group. So all my predicted values will look like this. But in the case of low bias and high variance, there will be, since it is condition low variance, low bias, therefore my predicted values will be lying closer to the actual value. But also it is condition of high variance, therefore the predicted values will having some gap relative to each other. They will be scattered. So my model will look like this. the values will be scattered with respect to each other. The first case here represents the condition of underfitting. Why underfitting? Because it is a condition of high bias and low variance. The last column represents the condition of overfitting. Why overfitting? Because low bias and high variance. And the third column here represents the condition of a good model, a model that has a perfect balance between overfitting and underfitting, a model that provides high accuracy. Before we get ahead, I want to give you a brief overview about what is overfitting and underfitting. So, in the next video, we will be dealing with overfitting and underfitting in a little more depth. But this particular section will give you a little intuition about what is overfitting and what is underfitting. So, suppose here there are three graphs, and the black dots represent the data set, the training data set. In case of overfitting, what the model will do is it will try to fit through each of the data set point. So my model's prediction will look like something like this. Here it tries to satisfy each and every point. So this type of model provides a very good, or I must say a really high accuracy in case of training data. But since this model is not generalized, its major focus was on the training data. Therefore, it will provide us a very poor accuracy in case of testing data, or we can say any random data. We can say that this overfitting represents the concept of a nice guy. I'm sure you must have heard about it. So what does a nice guy do? He tries to satisfy the needs of or the wishes of every other person that is situated near to him, or the people that are close to him. But when it's come to real life, when it's come to productivity, when it's come to dealing with a real life consequences, that guy is able to perform very poorly. That guy is not able to face the world properly. So this condition can be related to the concept of overfitting. Now let's talk about underfitting. So in underfitting, our model does not care where each or every data point is. It does not care. It moves along its own line. It does not care. So suppose these are my data point, my line will be like something like this. It does not care. It does not try to satisfy any points. It does not try to fit through each or every data point. It goes along its own flow. So this is a condition of underfitting. Don't worry, in the next video we will be dealing with these concepts in a little more depth, but for now only this much knowledge will be sufficient for you. So what is a good model? A good model provides us a proper balance between overfitting and underfitting. So here my model's prediction will look like something like this. Here you can see that my model does not try to fit through all of the data points. Neither it goes on its own flow. Here there is a proper balance between overfitting and underfitting. In case of overfitting, we have already discussed it is a condition of high variance, low bias. In case of underfitting, it is a case of high bias and low variance. And in case of a good model, it is a condition of low variance and low bias. So let us discuss the concept of bias-variance trade-off. So we want our model to give us good accuracy. So in order to achieve good accuracy, there should be low variance and low bias. So there should be a proper balance between a low prediction error and a high model complexity. So how can we increase the model complexity or algorithm complexity? So the complexity of a model can be increased by increasing the number of parameters. So if we have more parameters, or we can say more features, then their model complexity will increase. So here in the graph you can see that in the x-axis represents the model complexity. As we go along the x-axis, the model complexity increases. As we go along the y-axis, the prediction error increases. So here you can see that the red line, which I am drawing right now, represents the prediction error. So as I continue to train my model, and as I continue to increase my model complexity, my prediction error decreases. But after a certain threshold, after a certain point, my prediction error does not continue to decrease. It will now try to increase. Why? Because my model complexity is now more than the threshold. So my error will look like something like this. Here the first section, like this section, represents the condition of underfitting. So this whole left hand side represents the underfitting condition, and this condition represents the overfitting condition, this right hand side. Now let's talk about bias. So we know that in case of underfitting, my bias is high, and in case of overfitting, my bias is low. So my graph of my bias will look like this. Since it is initially in the underfitting condition, therefore my bias is high, but as I increase the model complexity, my variance increases and my model reaches the overfitting condition, therefore my bias decreases. It decreases and approaches to zero, but it is not equal to zero. In case of variance, if we talk about variance, in the underfitting condition, my variance is low, but as we reach the overfitting condition, my variance, the value of the variance is high. So my variance will look like, the graph of my variance will look like this. My purpose is to achieve a proper balance between optimum model complexity, less error, and a proper balance between low variance and low bias. So here you can see that this condition represents this whole line. This provides us a condition of optimum balance. So this concept is known as bias variance trade-off. So in this video we discussed what is bias, what is variance, how we use the bullseye diagram to discuss the concepts of bias and variance, and we also briefly discussed the concept of overfitting and underfitting, and at last we discussed what is bias variance trade-off. So that was all for today, guys. In the next video, we will be dealing with overfitting and underfitting. Until then, bye bye.